Hello, chemistry students. The next gas law we're going to talk about is Boyle's law, and it will connect the relationship between pressure and volume. This law only occurs when the temperature is constant, so keep that in mind. Boyle's law states that if the temperature of a gas is constant, the volume varies inversely with pressure. So, what does an inverse relationship mean? An inverse relationship is the opposite of a direct relationship. So, these properties will switch. If one of them is increased, the other one will do the opposite. Let's complete these sentences together. It's very important that this occurs at constant temperature. If pressure is increased, volume will decrease. At constant temperature, if pressure is decreased, volume will increase. So the mathematical representation of this law is P1 times V1 is equal to P2 times V2, where P1 is the initial pressure, V1 is the initial volume, and then the gas will go through a change, and you will have P2, the final pressure, and V2, the final volume. Here is a visual representation of Boyle's law. So, important to point out that this is occurring at constant temperature of 25 degrees Celsius. And this time, the thing that's changing is the pressure. So, the pressure begins at 2 atmospheres, then it's increased to 4 atmospheres, and this is being represented by weights on top of a movable piston. And then it's increased again to 6 atmospheres. The unit that they're using in this image to measure volume is decimeters cubed, but you can see that the volume is decreasing as the pressure is increasing. Let's practice some word problems. The pressure on 2.50 liters of N2O changes from 105 kilopascals to 40.5 kilopascals if the temperature does not change. What will the new volume be? Okay, so important to point out that the temperature does not change, meaning that we are going to be using Boyle's law. Next question is, what do they want to know? They ask, what will the new volume be? So they want the final volume. And then we just have to list out what we know. The initial pressure is 105 kilopascals, which is pretty close to atmospheric pressure. The initial volume is 2.50 liters. And the final pressure is 40.5 kilopascals. So in this case, the pressure decreased, so I will be expecting the volume to increase. We have all that we need, so we can plug everything into our equation. In order to get volume by itself, we've got to divide both sides by 40.5 kilopascals. And this will totally cancel out everything on the right side of our equation, and it will cancel out the pressure unit, leaving our final answer in liters. This is the part where I plug everything into my calculator and figure out what V2 is equal to. And I got 6.4814 liters. The story problem gave me 3 significant figures, so my answer will also have 3. 1, 2, 3. 1 does nothing to 8. So our final answer is V2 equals 6.48 liters. And that is just what we expected. It increased. One more practice problem. A gas with a volume of 4.00 liters at a pressure of 205 kilopascals expands to a volume of 12.0 liters. What is the pressure in the container if the temperature remains constant? The first clue here is that temperature remains constant, which means we'll be using Boyle's law. What are they asking us for? They want to know the pressure in the container. So they're asking for P2, and we should know everything else. The initial pressure is 205 kilopascals. The initial volume is 4 liters. And the final volume is 12 liters. Now we just need to plug everything in. I'm going to divide both sides of my equation by 12 liters. Which will cancel everything except for our unknown out on the right, and will cancel out our volume unit. Now this is the point where I'm going to plug it into my calculator and find out our final pressure. I can have 3 significant figures in my answer. So my So my final answer will be 68.3 kilopascals.